Statistics revolves around data. What's data? Well, anytime you fill out an application, you're asked things like your name, your address, your height, your weight, your age. All of those things are data. So data is really just information. And data comes in different types. If I ask you your age, you would give me a number. You would say 18, 21, 25, 30. If I ask you your major though, you would give me a word. You would say things like psychology, nursing, biology, business. So those are two different types of data. And it's going to be important for us to know what type of data we're working with because that's going to determine what we can do with it. For example, with the age example, we can talk about things like what's the average age of students in this class. But if we're talking about majors, it doesn't make sense to ask what's the average major. We can talk about what's the most popular major, but the average wouldn't make sense. So today, we'll talk about the different types of data. There are two main types of data, qualitative and quantitative. I'm going to start with quantitative. The word quantitative comes from the word quantity, which means how many. So quantitative data are going to be numbers. And these are numbers that count or measure something. Which is why sometimes quantitative data is called numerical data. And because they're numbers, it's going to make sense to do math with these numbers. And by this, I mean things like taking an average or subtracting. Dot, dot, dot. And I mentioned one example already. So an example of quantitative data would be age. Okay. Age is a number, and it measures how long you've been alive, how many years you've been alive. Other examples of quantitative data, height, distance. These are all numbers that count or measure something. The other big type of data is called qualitative. And these are going to be usually words. And these words are usually labels for categories. So which is why qualitative data is sometimes called categorical data. And I mentioned one example of this also. When I ask you, what's your major? You would give me a word. You would say things like psychology, business, nursing. What city do you live in? You would also give me a word. Most of the time, categorical data or qualitative data are going to be words. But sometimes they can also be numbers. And you may be asking, what do you mean they can be numbers? Well, they can be numbers if the numbers are just used as labels. And let me give you a couple of examples of this. So Steph Curry, basketball player, he wears jersey number 30. Okay? LeBron James, also basketball player, he wears number 23. Now, this 30 and this 23, do they count or measure anything? And another question we can ask is, would it make sense to do math with these numbers? So Steph Curry's 30, LeBron James 23, would it make sense to maybe subtract them? If I subtract them, I get 7. What does this 7 mean? Does 7 really mean anything? The answer is no, right? Because these jersey numbers, 30, 23, right? They're not counting or measuring anything. They're just used as labels. So jersey number will be an example of a number that's not counting or measuring anything, but it's just used as a label, which means it's going to be qualitative. Another example, your zip code. I live in 95835. So 95835. Does that count or measure anything? No, it doesn't. It doesn't count or measure anything. I know CRC is in 95823. Okay, if I subtract those two zip codes, does it mean anything? So 95835 subtract 95823, I think is 12. Does that 12 mean anything? Does that mean I live 12 miles away from CRC? I know for sure that's not true. So zip code is an example of a number, but it doesn't count or measure anything, which means we're going to call it qualitative because it's just a label for an area. Another example, your student ID number. Okay, W and then a bunch of numbers. Those numbers, they're numbers, but do they count or measure anything? Would it make sense to do math with those numbers? Like, would you take your ID number, your friend's ID number, and take their average? And if you do, does that average mean anything? Or if you subtract them, does that mean anything? Would you ever do that? And the answer to all of those is no. So all of these are examples of numbers, but because they don't count or measure anything, we'll consider those to be qualitative, right? Because they're just being used as a label. All right, so those are the two big categories of data, and each category is broken up further into smaller subcategories. So qualitative data is broken up into ordinal and nominal. Okay, so these are most of the time words. Ordinal means that there is a natural order. An example of this would be if you go to Starbucks, right, and you order a drink, you have to give them a size. So Starbucks cup size. So Starbucks cup size are words. I think your options are tall, grande, venti. But there's a natural order to this. So when I say natural, I mean there's an order that everyone agrees upon, either like from smallest to largest or largest to smallest. So tall, grande, venti, that's in order from the smallest cup size to the largest. So tall is the small, grande is the medium, venti is the large. And I think there's actually two other ones. There's like short, which is like even smaller than tall, and then I think there's a bigger one. I don't remember what it's called. Okay, so Starbucks cup size. There are words, but there's an order to these words that everyone agrees upon, from smallest to largest or largest to smallest. Another example, t-shirt size, right? T-shirt size, small, medium, large, extra large. That's in order. And that's ordinal. So it has the word "ord" for order. Nominal, it doesn't have an order. So nominal, there is not a natural order. An example of this would be majors. Okay, major, psychology, business, biology. Is there an order that everyone would agree upon? Now, I'm not going to count alphabetical order as an order, because if I do count alphabetical order, then everything is going to be ordinal. So outside of alphabetical order, is there an order to majors that everyone would agree upon? So psychology, business, biology. Is there an order to those three majors that people would agree upon? No, right? City. Okay, outside of alphabetic order, is there a order to cities in California, for instance, that people would agree upon? I would say no, because there's different ways you can order cities, right? You can order it based on population size. You can order it based on location, from north to south, south to north. You can order it based on when these cities were formed in terms of like the date or year that they were formed. So there's no one natural order that everyone would agree upon for cities or majors. So those would be examples of qualitative data that are nominal because they don't have a natural order. Quantitative data is broken up into two subcategories, discrete and continuous. And these have to do with the possible values. Let me start with continuous. Okay, continuous, so these are numbers, remember, these are all quantitative data. Continuous quantitative data, the possible values are any decimal. And I'm going to put here in a range. And I'll explain myself in a little bit. So if I talk about something like weight, these have to do with the possible value. So ask yourself, what's a possible weight? Well, one possible weight would be 160 pounds. Okay, that's a possible weight. But does it make sense to have decimals also? So does it make sense for a weight to be 160.2 pounds? Yeah, right? Does it make sense to have a weight that is 160.231 pounds? Yes. So for weight, it makes sense to have any decimal as a weight, right? So 160.231 pounds makes sense as a weight. That's why it's called continuous, okay? And when I say in a range, I mean, of course, you can't have a -5 pounds, but in a range where it makes sense, could you have any decimal in that range as a weight? And the answer is yes. So if the answer is yes, it's continuous. If the answer is no, it's discrete. So discrete is basically not continuous, but discrete, the possible values are isolated numbers. For example, if I ask you, how many cars do you have at home? What possible answer would you give me? If I ask you how many cars you have, possible answers would be 0, 1, 2, 3, 4. You wouldn't say, I have 2.3 cars at home. Or you wouldn't say, I have 2.315 cars at home. Right? It doesn't make sense for you to give me any decimal as an answer. Right? You would only give me whole numbers. And that's mostly, most examples you'll see of discrete will be types of data where the possible answers will be just whole numbers. If I ask you, how many students are in this class? You would tell me 33. 44, 45, right? You wouldn't say there are 44.918 students in this class, right? It doesn't make sense. So the possible values are not going to be any decimal. So most of the time, if the possible values are just whole numbers, it's going to be discrete. The only example that I could think of off the top of my head where you can have some decimals, but it's discrete, is shoe size. What are the possible shoe sizes? If you go to the shoe store, possible shoe sizes are things like 7, 7.5, 8, 8.5, 9, 9.5. Right? The possible values are whole numbers and then some decimals. So whole numbers and halves, right? But you wouldn't go to Foot Locker and say, hey, can I get this shoe in size 8.519, right? You can either use whole numbers or whole numbers in half. So this is another example where because you can't have any decimal, right? You can't have 8.519 as a shoe size. This would be discrete. All right, so those are the different data types that we'll be working with. So now let's try an example. What I have here are some descriptions of data. And what I want to do is go through each description and decide what type of data we're dealing with. So what I need to decide first is, for each description, whether we're dealing with qualitative or quantitative data. If it's qualitative, I need to also decide whether it's ordinal or nominal. If it's quantitative, I need to also decide whether it's discrete or continuous. So for each description, I'm going to need two words. Part A, number of students at CRC. Number. So remember, number alone doesn't mean it's quantitative. The number, for it to be quantitative, the number has to count or measure something. So number of students. Would this number be counting or measuring something? Yes, right? Number of students is counting how many students are at CRC. This is a number that's counting something, which means it's going to be quantitative. For quantitative data, they can either be discrete or continuous. And a question you should ask yourself here is, would decimals here make sense? If we're talking about number of students, would you ever say 43.189 students? No, right? We're talking about number of students. Numbers that would make sense here would be 1,000 students, 100 students, 105 students. Whole numbers would make sense here. So this would be discrete. Okay. If decimals would make sense, then it would be continuous. If your answer to that is no, it's discrete. Part B, the MPAA rating of a movie. G, PG, PG-13, R. These are words, definitely not numbers. So this is for sure qualitative. And for qualitative data, we have to decide whether they are ordinal or nominal. And the question you should ask yourself here is there a natural order to G, PG, PG-13, R? Is there an order that everyone would agree upon? Yes, it's already in order, right? G, PG, PG-13, R. So it's in order of how appropriate it is for kids, right? So G is most appropriate for kids. R is the least appropriate for kids. So there's a natural order, which means this is ordinal. Part C, your social security number. It says number, but remember, number alone would not make it quantitative. You have to ask yourself, does this number count or measure something? So your social security number, does that count or measure anything? And if that question is not helping you, ask yourself the second question, which is, would it make sense to do math with these numbers? For example, would it make sense to take two social security numbers and average them? Or would it make sense to take two social security numbers and subtract them? Like, would you ever do that? And would the answer mean anything? And the answer to all of that is no. Social security number is not counting or measuring anything. It's just used as a code. Okay, so this would be, so it's a number, but because it doesn't count or measure anything, and you wouldn't do math with this, right? You wouldn't take two social security numbers and subtract them. This is qualitative. Because it's qualitative, I need to ask myself, is it ordinal or nominal? And just like when we're talking about qualitative that are words, I'm not going to count alphabetical order as an order because then everything will be ordinal. So when we're talking about numbers that are qualitative, I'm not going to count numerical order as an order either, because then everything will be ordered ordinal also. So outside of numerical order, is there an order to Social Security numbers that people would agree upon? I don't think so. Right? Other than numerical order, I can't think of any other way you would order Social Security numbers. This would be nominal. Part D, classes you are taking this semester. Statistics, biology, history, English. These are definitely words, so this would be qualitative. Because it's qualitative, we have to decide whether it's ordinal or nominal. Question we should ask ourselves here is there a natural order to these classes? And remember, we're not going to count alphabetical order, so outside of alphabetical order, is there an order to statistics, biology, history, English that everyone would agree upon? No. This would be nominal. Part E, the time you spend on YouTube. So time like hours. So if we're talking hours, we're talking about numbers, right? Would this number count or measure something? Yeah, so it's counting how long you spend on YouTube. So this will be quantitative. And then for quantitative data, we have to decide whether they are discrete or continuous. And a question we should ask ourselves here is, would decimals here make sense? So time spent on YouTube, so hours, would it make sense to have 10.351 hours? For time, yeah, that makes sense, right? It makes sense to say I spend 10.351 hours on YouTube. So because it's a yes, this is continuous. And that's all the different types of data. Have a great day, and I'll see you in the next one.